first we're going to do what we stopped doing stuff at the end yesterday. We were talking about how we could make conversion factor, or moles to moles. And then we're going to add it to the gram stuff that we did in the past. So we've already learned most of the new stuff in this chapter. It's in the first, everything else is just an outcome of that fact that we can read these in moles. So if you want to do mole to mole conversions, you're not changing the mole, you're changing the chemical. So, and what you use is you use the coefficients to convert moles of one chemical to moles of another. So today, I'm going to try to use the same equation over and over again. So we're going to use this equation most of the day. Okay, and this is the equation for what happens when you use cutting torches. C2H2 is acetylene. Take acetylene, if you've ever seen cutting torches, they always have two hoses running to it. One for fuel, one for oxygen, two tanks. One full of acetylene, one full of oxygen. So you need to have the right amounts of both acetylene and oxygen. Well, you're going to run out of them at different times. Okay. So if 3.84 moles of C2H2 are burned, how many moles of O2 are needed? I start off by writing down what they give me. They gave me 3.84 moles C2H2. What unit do I want to get rid of? One I have. That moles of C2H2 has got to go on the bottom so it'll cancel out. So whatever I wrote here, I got it right there. And what would I like to turn it into? I'd like to turn it into moles of another chemical. And I can do that because I have a balanced equation. And my balanced equation says I can go from moles of C2H2 to moles of O2, because there's 5 moles of O2 for every 2 moles of C2H2. In every other kind of conversion factor, mole has a 1 next to it. When you're going from mole to mole, you can put numbers besides 1. Now I got the units they asked me for. Got moles of O2. So all I have to do is push buttons. Type in the 3.84 they gave me. And the 5's on top, so I multiply by it. And the 2's on the bottom, so I divide by that. So 3.84 times 5 divided by 2 is 9.6 moles of O2. I'd usually put the 0 in because this had 3 things over here, so I want 3 over here. But usually really, really difficult. Okay, so that's if I had one reactant and I asked about the other reactant. Okay, I could have asked if I wanted this to make water. It's a lousy way to make water. But if I wanted to make water, what would I need to do? Well, how much C2H2 would I need to make 8.95 moles of H2O? So same reaction. So 8.95 moles of H2O. I want to get rid of moles of H2O. So whatever was here, it's got to go there. And moles of H2O I can turn into moles of what they asked me for, C2H2. And the number in front of H2O is a 2. The number in front of C2H2 is a 2. And I could push 8.95 times 2 divided by 2, but I'm not going to, because 2 over 2 is 1, so it's going to work out to be 8.95 moles of C2H2. And that makes sense. If I use 2 moles of C2H2, I'll make 2 moles of water. So if I use 8.95 moles of C2H2, I'll make 8.95 moles of water. If 2 makes 2, then 8.95 makes 8.95. Make sense? Okay, just make sure it makes sense. So you guys complete this one. So, do this one. Make sure we got the big idea. Where's it got to go? So my units tell me how to do the problem. I got moles of C2H2. I'm going to put that on the bottom. They asked me for moles of another chemical. They asked for CO2. I'll put that on the top. I got my balanced equation. 4 for CO2 and 2 for C2H2. And if you push those buttons, you should get 5.94 moles of CO2. 4.94, yeah. I carried twice. So that's what happened to do in my head. I carried twice. Extra is super hard. Hugely different than what we've been doing for 3 weeks. Okay. Well, we only have one problem. We can't measure moles. Because remember, moles is just a huge number and counting's not an option, right? So big that counting's not an option. So what can we do? It works in moles, but we can't measure moles. What can we measure? We can measure grams, right? And those grams, we can turn into moles, right? I can't measure the moles directly, but I can measure the grams, do some math and figure out how many moles there are. Where am I going to get the numbers to do that? Where do I get the numbers to turn between grams and moles? Periodic table. Add up the molar masses, right? Use that molar mass. The periodic table, and remember the periodic table is for 1 mole. So I'm going to put 1 next to my conversion factor. Okay. Now I got moles. then I'll be able to change chemicals, yeah. Well, actually, when you let the conversion factors decide for you. Okay? So you do 1 mole is this much, and then you deal with the 2 in the next conversion factor where you use moles to change chemicals. And that's where you're going to use the 2 from the balanced equation. So this is the only one where moles does not have to equal 1. Moles equals whatever it says in front of it. It might be 1, but it doesn't have to be 1. Grams and moles, it's got to be 1. And then I got those moles, I'll be able to turn those back into grams. Because if I get moles as an answer, I won't know if I have that many moles unless I weigh it, right? And where do I get numbers to turn moles back into grams? From the periodic table. And again, it's going to be 1 mole is how heavy, is as many grams as there are on the periodic table. So here's a diagram of exactly the same information. I start off with grams of chemical A, mass. First thing I'm going to be able to do is turn those into moles of chemical A, using the numbers off the periodic table. Then I'll be able to turn the moles of A into moles of B, using the balanced equation. And then I'll be able to turn the moles of B back into grams of B, using the periodic table. Now, on the last couple problems, we started here and ended here, right? We just did 1 conversion factor and we got our numbers from the balanced equation. All the examples we've done so far. So this diagram works no matter where you start or no matter where you end, right? Just pick where to start based on what units they give you. Let the units tell you how to do the problem. Whatever unit they give you, that's what's got to go on the bottom. And that'll tell you where to start on your diagram. And you stop when they ask for it. So last one they told us moles, so I started here, and they asked me for moles, so I stopped here. I only needed 1 conversion factor. Make sense? So to get from moles to moles requires 1 conversion factor. But what chemists usually do is start with grams. So back to our same equation. It's going to look just like the last one. How many grams of C2H2 are needed to produce 8.95 grams of H2O? So we just did this one a second ago. No, we did 8.95 moles. That's 8.95 grams of H2O. So start off with the 8.95 grams of H2O. Okay, before we start going, let's make our plan. Where am I starting? Well, I've got grams, so I'm starting at mass of A. Where am I finishing? Grams, so I need to go there. So I'm going to need 1, 2, 3 conversion factors. My first one to change into moles, my second one to change what chemical it is, my third one to change it back into grams. So I want to get rid of grams of H2O. So it has to go on the bottom. And it says I'm going to go from grams to moles, so apparently I'm going to put in moles of H2O on top. And 1 mole, well, 2 H's is 2.02 grams. 1 O is 16.00 grams. So it's 18.02 grams for 1 mole of H2O. And my next one says I'm going to go from moles to moles. Moles of A, one chemical, to moles of B, a second chemical. So I'm going to get rid of those moles of H2O that I have left over. The units I have left are moles of H2O. And I want to change those into moles of a different chemical. And the chemical he asked me about was C2H2. And in my balanced equation, it's 2 moles of C2O, 2 moles of H2O. So unit-wise, I'm at moles of C2H2. Now, I want to get rid of moles of C2H2. And it says I'm going to go get grams. I get grams off the periodic table. 2 C's is 24.02 grams. 2 H's is 2.02 grams. That's 26.0204 grams. 1 mole of C2H2 is 26.04 grams. And I go pushing buttons. 8.95. The 18.02 is on the bottom, so I push divided by 18.02. There's a 2 on top, times 2. There's a 2 on the bottom, divided by 2. I didn't have to push those. Times 26.04 equals 12.9 grams of C2H2. So the reason why we changed it into moles is because with moles I can change the chemical. All right? Okay. If 2.47 grams of C2H2 are burned, how many grams of CO2 are formed? So we're still doing grams to grams. So it's still going to take us 3 steps. Doesn't always take us 3 steps. This is where chemists do most of the work, though, because grams are easy to weigh, right? Grams are easy to find. Weigh a dish, put some stuff in it, weigh it again, subtract the dish. So if 2.47 grams of C2H2 so every one of those little arrow hops is a conversion factor. I want to get rid of grams of C2H2, and grams I can turn into moles. And 1 mole we just figured out was 26.04 grams. Just figured that out a few minutes ago. And my grams of C2H2 have canceled out. Now the unit I want to get rid of is mole of C2H2. Moles of C2H2 I can turn into moles of a different chemical, and they asked me about CO2. Those numbers I get from the equation. So the number in front of CO2 is a 4, and the number in front of C2H2 is a 2. And my moles of C2H2 have canceled out. Now the unit I want to get rid of is moles of CO2. So it's got to go on the bottom. The unit I want is grams of CO2. Put that up top. I can do that. Add up CO2, carbon's 12.01 grams. 2 oxygens would be 32. 32 and 12.01 is 44.01 grams for 1 mole of CO2. So pushing buttons, 2.47 divided by 26.04 times 4 divided by 2. Yep, if you can do it in your head. And I get 8.35. Okay. So the only way they could change these problems is, instead of giving you grams here, they could change this to moles of C2H2. If they change this to moles of C2H2, then you'd just be able to skip the first step, right? If you've already given moles, you're starting here. Okay? So that's what you're going to do today. Practice those, because tomorrow what we'll add to this is we can also do liters and molecules, right? So we must do those too. So that's what we're going to do the next couple of days. Putting this stuff together from last unit and that mole thing. But, yeah. Okay, so I put that same diagram with actually more information right on top of the paper for you. It tells you what the unit should look like in your conversion factor. And the numbers in parentheses are the answers. Yep.
We already have that.
Already have the answers for a lot of them, yeah. Because I want to see if you can set, because I'm going to look at the word. I'll look at the word. So on that first one,